Well, like most people, I grew up thinking fruit was some kind of food, some kind of healthy snack, and I think that's how it's perceived by most people. It's rarely discussed outside basic healthy snack, a little bit of basic nutrition. Fruit is in fact the reproductive organ of flowering plant. It has a lot of extremely unique characteristics. It's a highly evolved, highly designed organ. Very basic analogy, it's sort of the equivalent to the mammalian uterus, not exactly but near enough. So it creates an environment for reproduction. It's evolved to read the plant DNA in quite a different way. It's not reading the DNA to produce roots or leaves or bark. It's kind of reading the DNA to produce a whole new generation of the plant. Humans, primates generally, have formed various symbiotic relationships with the flowering plants, particularly with fruit. They're regarded as primary seed disseminators, so that's the basis of this symbiotic relationship. When you're effectively ingesting several kilos of reproductive organs every day, 24/7 for millions of years, what you're effectively doing is taking your own DNA and immersing that in the reproductive environment of a whole other kingdom. It's affecting, in our case, the mammalian endocrine environment. You're infusing it with the plant's endocrine environment, and the more specialized that relationship gets, the more fruit you're ingesting, the bigger the impact. And by the nature of hormones and hormonally active compounds, you're pretty much changing everything. You're changing the way the DNA is read, you're changing the timing of when it's read and how long it's read for. And the mechanisms that have been elucidated strongly support the idea that forming this relationship would, in a very general way, extend some of our key developmental windows. So, for example, the period before we reach sexual maturity would be progressively extended. That's very important because it provides the window for neural development. It looks to me like extending juvenile windows is incredibly beneficial if you want to build a very big brain, a very big neural system. It also opens the door to maybe explaining some of our unusual traits that have been well documented. The term generally covering this is neoteny. It's the retention of juvenile traits into adulthood. A lot has been written on this. There's been quite a bit of speculation that it's in some way correlated with having a very large brain. There's other traits as well, things like our hairlessness, relatively flat face. Again, the obvious one, very long juvenile phase. This is something relatively unique in humans. And bearing in mind that the plant's reproductive environment is, in a very simplistic way, it's like a juvenile inducing environment. It's evolved to induce the juvenile expression of the plant's DNA. And plant and animal DNA, for all the arbitrary differences, it's basically the same molecule. So while it won't have exactly the same impact, our mammalian code is obviously distinct. The general trend towards juvenility makes an awful lot of sense. However, I go beyond that and say it's not just a kind of philosophical idea. The mechanisms that we currently understand and some of the biochemistry that we know to be in fruit, classes of compounds like flavonoids, they're known to dampen down, inhibit, modulate our own mammalian steroids like testosterone and estrogen. So there's very tangible mechanisms coming out of this. It's not just, okay, juvenile inducing environment, we have juvenile features. Interesting correlation. Beyond that, some very tangible mechanisms. So the biochemistry of fruit begins to inhibit our very own steroidal hormones, and they're strongly implicated in the very major developmental windows and structure. They basically play a major role in reading our own DNA, deciding the duration of our developmental windows, including our juvenile window, a juvenile phase, and ultimately dictating the kinds of structure that develop. One of the many roles steroids play is in differentiation or specialization, where cells go from relatively juvenile, relatively unspecialized, and as the steroid regime kicks in, usually it's sexual maturation and other windows as well, we get specialized structures forming, which of course is very useful and probably very necessary. But in terms of our symbiotic relationship, forming this relationship with the reproductive organs of the flowering plants, the general trend would be taking a specialized mammal and beginning to add in on top of that some juvenile features. And I think that's exactly what happened. The fruit began to modify our standard mammalian developmental window, extending it, allowing us to grow a bigger brain. And equally, if not more important, the kind of neural system we began to grow was, again, to put it simplistically, a juvenile brain. It was kind of undifferentiated or relatively undifferentiated juvenile tissue. What we know from our own juvenile phase as it currently stands, the juvenile neural system runs the endocrine system in a juvenile way. It maintains a juvenile environment. So the basic idea is we get this slow emergence of a juvenile layer. It's an executive layer. It begins running everything else. And in addition to the direct juvenile effects of the fruit biochemistry, this new neural system also begins to run a more juvenile endocrine system. So that's kind of feeding in and opens the door to kind of a rapid acceleration in juvenile traits as it gathers momentum. I think initially the effects would have been very small. It would have taken a long time to reach critical mass. But as this new layer expanded and became progressively juvenile, it began to accelerate this juvenile trait, allowing greater extension of these developmental windows and increasingly undifferentiated juvenile neural tissue, which is exactly what we see, particularly in human evolution in some of our relatives. Rapid and accelerating expansion of the neocortex, this new layer of brain, relatively undifferentiated, with the potential to run the endocrine system in a way that feeds back into that whole mechanism.